Hello everyone, welcome to the channel. For this tutorial, I'm going to show you how to copy files from one location to the next using C. So the first thing I want to do is include some of my packages. So I'm going to say include, and I want the stdio.h header file. And this header file is going to give me the functionalities for the file structure. Also, I need the function for fopen, fclose, fwrite, and stuff like that. These functions and structures is defined in the stdio.h header file. Then I also want to include stdlib, and stdlib gives me the header file you have to use when it comes to managing speed, right, and memory. So I'm going to say stdlib.h. So these are the only two header files that I would need for this program. Now I'm going to create a function, and it's going to return an integer, and I'm going to call my function copy file. And inside of this function parameter, I want two variables. The first one is going to be a const, and I'm using const. Well, it's called constant. I do not want the value to be changed. So if you do not want that value to be changed in your program, the value of that variable, you make it a constant. And then I'm going to declare my variable a char pointer, and I'm going to call my variable source, and I'm going to declare another variable which is going to be constant, and I'm also going to make it a char pointer as well, and I'm going to call this variable destination. Now, what these two parameters mean: the source means where is this file located, and destination means where am I going to put this file. That's what this function is doing. Pretty self-explanatory. Source, where is it coming from? Destination, where am I putting it? Okay, so now inside of this function, I'm going to declare a file variable, and I'm going to have it as a pointer, and I'm going to name this variable file underscore source. Now this file keyword here, this is a structure that is located in the stdio.h. This is not a function. This is a structure. Now the file variable, which is file underscore source, I'm going to initialize it to the fopen function. Now fopen is also located in the stdio.h header file. Okay, so fopen is a function and file is a structure. Now inside of the fopen function, I want my source, right? So that's where the file is located, and I want to open this file read and binary. That's what RB stands for. So after this, we're going to have if statement. As always, when you're writing any type of program, you have to do some checks. You cannot just do things freely in C or C++. We have to check if the file is available first before we do anything. So let's check if the file is available. And to do that, we have the if statement, and we say if not file source. So if the path is not there, then we're going to just give a simple printf statement and say we cannot open the file. So printf, and instead of the printf function, let's just say cannot open file. That's it. Okay, and then we can probably just give a \n here, and we just want to return 1 to the program or to the caller. So this is what this int is doing. We're going to return an integer to close the program. So we're going to say return 1, and that will close off the program. This here is just to check if the file is available or not. Then if the file is available, we want to put it in the destination. Okay, so we have to declare a file variable. So we're going to call this variable file destination. And for the file destination, we're going to have it initialized to fopen. Inside of the fopen function, we want the destination, and we want to write binary. Write binary and read binary. This ensures that it works for any type of file. It could be an image, it can be a PDF, it can be an executable file, any type of file. Now, once we finish with this line of code, we want to check if the destination is available. So just as how we have to check if the source is available, we also have to check if the destination is available as well. So we can write another if statement. So if not file destination, we want to write some messages and close the file. So we're going to say printf, and inside of the printf function, we can say cannot open file destination. And then let's just do a \n. And that's it for the printf function. Then we want to close the file. So anytime you open a file, you must close it. So we have to call the close function. And inside of the close function, you want to give which file to close. Okay, so we're going to say file source. And we're just going to end the program with return 1. Okay, now after we finish do that, let's say the source path is correct and the path for the destination is correct. Now we want to copy the content from the source file to the destination file. So this is the code to do the copying. So the first thing we want to do is declare a char variable. We're not going to make it a pointer, and we're going to call this char buffer. Okay, so what the buffer is doing is just a temporary storage for chunks of the file. So stuff that's in the file, we're going to kind of put it in the buffer. And then from the we're going to take it from the buffer and then put it into the destination. Okay, so in the buffer, we can say 4096, and that is just reading the bytes. Okay, so we're just going to take the bytes one by one from the buffer and put it into the destination. So repeat until it reach up to 4096. So from there, we're going to declare a size t, size underscore t, and we're going to call this variable bytes. The size t variable just simply means unsigned integer type, and that can represent the size of an object, the size or the length of an array, or the memory block size. It's defined in stdio.h and in the stdlib. After that, we're going to create the while loop to get the information from the buffer into the destination. So I'm going to say while, and inside of this while loop, I want to get my byte variable, and the byte is going to equals to fread. So we're going to read what's in the buffer, and inside of the fread function, I'm going to say buffer because I want to read what's inside of that buffer, and I'm going to use 1. Now, why use 1? Why did I put 1? The 1 just means that I want to read raw byte. The 1 controls how many bytes per element are read from the buffer. Okay, I want to do it 1 by 1 up to 4096. This guarantees that the copy is exact, no interpretation. I want to do it byte by byte. I do not want to do it chunk by chunk. You can do this chunk by chunk. Let's say the bytes is up to 4096. Some programmers do it 1024 when they're reading from the buffer. Okay, so you reading it by 4 bytes. In this case, I do not want to do it like that. Doing it this way can be a little bit risky. So I want to do it 1 by 1. After the 1, we want our size of function. And inside of the function, we are reading the size from the buffer. So I'm going to say buffer. And I also want the file source. So as long as that information is greater than 0, so that means there is stuff in there. So as long as this is greater than 0, then we want to write the stuff from the buffer into the destination. So here I'm going to say fwrite, and I want to write what's inside of the buffer, and I also want to read this byte by byte. So 1 by 1. I also want my byte variable, and I want to place this in the file destination. And then I'm going to end this. This is all that you need to get the file from the buffer into the destination. And then you have to close the file. So I'm going to say fclose, and I want to close the source. So I'm going to say file underscore source. And I also want to close the destination as well, because you cannot leave files open in your program. You have to close it. So here, close destination. And in my function, I want to return 0. Now, inside of the main function, it's going to be pretty simple, just a couple lines of code. So I'm going to call my copy file function, and inside of the copy file function, you have to put your where the file is coming from, so the source, and then the destination. So before I use this, so let me just put my return statement, and let's go and create a file with their location. Inside of this folder, I'm going to create 2 folders. I'm going to call one of the folder source, and I'm going to call another folder destination. Inside of the source folder, I'm going to create a simple text file. So I want a new text file. I'm going to call this text file readme.txt. So inside of this text file, I'm just going to put a simple statement saying hello from source going into destination. Then I'm going to save this file. Now, inside of the destination folder, we're going to create a text file as well. And I'm going to call this text file this for destination readme. So this is going to be the destination readme.txt file. I'm going to come here and I'm going to copy as path. I'm going to go into here and I'm going to paste. Okay. So this is the path. It's on the C drive. Now, when you're writing programs, you also have to make sure that it's a double backslash. The compiler is going to look for some type of characters. So this is our source. Now let's put the file somewhere. We want to put it in the destination folder. So let's go inside of the destination folder here. So let's copy the path for this location and we're going to paste it. And here we're going to do the same. So double backslash, double backslash. Now this is all for copying files from one location to the next. So let's go ahead and build a program. You know what? Let me put this side by side. I'm going to run this program because I already built it. And I'm going to say start without debugging. And let's see. Okay. So our program ended successfully. We didn't get back any of the messages from the printf. Now let's close off and go into the destination folder. And let's look at des_readme.txt. And here we have our stuff that we copied from the source.txt. So if I go back and if I open the readme.txt in the source file, the exact same thing. So this is how you copy files from one location to the next. Now, the reason why I'm writing these small programs, if you want to learn any type of programming language, it's always best to write little mini programs instead of learning the syntax. It's always best to practice writing little programs. So that's it for this video. If you have learned something, please don't forget to like, subscribe, share, and I will see you in the next tutorial.